Okay, we're going to take a quick look at some of the common sampling methods that are often used in an introductory statistics course. Now, before we look at the methods, we want to keep in mind that the goal of sampling is that we want to try to get a representative sample. So what this means is that the characteristics of the sample would mirror those characteristics of the population. And we've seen that a small representative sample is generally better than a large biased sample. So if you remember back to when we talked about the election of 1936, the Literary Digest sampled 2.4 million people and were way off on their prediction, whereas George Gallup sampled 50,000 people and was right on with his prediction for that particular election. So a small representative sample is generally going to give you better results than a large biased sample. Okay, and now even if you use a good sampling method, there's still going to be the possibility of what's known as a sampling error. And this sampling error is basically when we go through the right steps, we go through the right process, but our sample does not turn out to be representative. Okay, so the common methods. The first one that we're going to look at is called simple random sampling. And the idea behind this is that every member of the population has the same chance of being selected. So some examples that you might think of would be if you had everybody's name on a slip of paper and pulled a name out of a hat. That would be an example of random sampling, because each ticket that's in there would have the same chance of being selected. We can use what's known as random number generators to electronically generate random samples. So every individual would be assigned a number, and then we would use a random number generator to select which numbers would be chosen for our sample. There's a lot of different ways to get or to do simple random sampling. So as long as every member of the population has the same chance of being selected. Now we can also use systematic sampling, and with this we typically will follow a rule. So maybe you would have an alphabetical list of all the people in your population, and then you decide that you're going to pick every fifth person on the list. So that would be our rule that we would be following. So that would be systematic, because we're going to follow this particular rule and every fifth person is going to be in our sample. Okay, and then we could also do what's known as convenience sampling. Basically, that's whoever is most readily available. This is typically not a good method to use because there's a lot more potential for bias in convenience sampling than with our other methods. So convenience sampling might just be, maybe you're going to ask the people who are sitting next to you, whatever your survey might be. Maybe you are going to go to the basketball game and ask the first 20 people that walk through the door. Okay, so that would be convenience sampling because it's what's most readily available. Generally not a good idea to do that one. Okay, we also have what's known as stratified sampling. And with stratified sampling, there's a couple of steps that go into this. The first thing is that the population has to be broken up into what's known as strata. So strata, those are categories that are based off of personal characteristics. The key here is that they are personal characteristics. Those could be examples of like gender, grade, income level, religion. So any of those would be considered personal characteristics. Once we have our population split up into the different strata, then we use random sampling to obtain some individuals from each of the strata. So maybe you would, if you were asking that question about school lunch, maybe you would break the population up into freshmen, sophomores, juniors, and seniors, and then you would ask 10 freshmen, 15 sophomores, 10 juniors, and 10 seniors, or something like that. So they've been broken into strata, and then we use random sampling to get some information from, or to get a sample from each of the strata. Now, this is often confused with what's known as cluster sampling. So with cluster sampling, again, we're going to break the population up, but this time we're going to break the population up by clusters. Now, the difference is that a cluster is a group that's based off of physical location. So strata was based off of personal characteristics. Cluster sampling is based off of physical location. So this might be, maybe we break the state of Iowa up into counties. Maybe you break your high school up into classrooms or lunch tables or city blocks. Those are all based off of physical locations. Okay, so once we get our population broken up, then we randomly select some of the clusters, and then we sample all the individuals within those selected clusters. Okay, so stratified sampling and cluster sampling are the ones that people will usually get confused the most. So you want to make sure that you remember the different components that go for each of those. And then in real life, most of the time we use what's called multi-stage sampling, which is where we use a combination of these different sampling methods. Now keep in mind, these are not the only sampling methods that are out there, but they are the most common ones that you'll see in an introductory statistics course. Okay, so what we looked at was just what a representative sample is and why that would be important. We looked at the variety of different methods that we'll often see in introductory statistics. And then just always keep in mind that there's still going to be potential for sampling error, which could possibly lead to biased and bad results.